Now, I'm going to present Jake, but I'm going to do it in Bulgarian. И преди да кажа нещо за Джейк, искам да ви разкажа няколко шеги. Колко от вас са гледали Властелина на пръстените, между другото? Колко от вас са гледали Властелина на пръстените? Знаете ли какво става, като се съберат 8 хобита? Става един хобайт. А знаете ли какво е терапевт? Това са 1024 гигапевта. Добре, не ми се получи, иска да ви накарам да се разсмеете, за да се чуди Джек, що се смеете, но вие не искате да се действате, както и да няма значение. Yeah, it was just random nonsense, but didn't work out.
Sounds good.
Here you go.
I told him that if y'all laughed while I was standing here and he was speaking in Bulgarian, I would get a little paranoid, so he decided to start off with jokes and random stuff. My name is Jake. I'm here to talk about modern JavaScript testing. You can find me on Twitter, Jake Luer, or GitHub, I am Logical Paradox. Before I begin, I wanted to start with a little bit of an audience participation section. I want to know how many people here think write JavaScript as their primary language? 4, 5, 6, awesome. How many of you write tests for your JavaScripts? Good. That's good. All right, how many people here don't think that JavaScript is their primary language, but have to deal with it in their job or their workplace or whatever? So, okay. This side and this side, it's going to be a competition. And of this side, tests. How many people see tests, write tests for their JavaScript? Not as many. All right. Well, that means that some of you have something to learn today. That's awesome. That means that I have something interesting to say as well. First of all, we need to talk about what is modern JavaScript. JavaScript obviously has been around for a very long time. And it sort of went through this progression. And it started out with just being basic in the browser, and then we got into more advanced things like Ajax and jQuery and all that kind of stuff. Now, it's much more advanced. We have full client-side stacks. We have Node on the server side, and JavaScript has become more complex. One could even argue that it has become one of the first-class citizens of the primary languages. Not necessarily because of its beauty or its power, but because of its ubiquity. It's everywhere. It's in browsers, phones, etc. So for our modern JavaScript stack, we're going to say that let's pretend that we can run JavaScript everywhere. So for the client side, we're going to have our MVCs. We're going to have these advanced data models that you've seen in other applications. You've seen state synchronization, databases, stuff like that. We're also going to see modular and reusable client-side templating. You want your client to do the rendering. You want your server to do the computation. And also HTML5 is fantastic because you have things like WebSockets for real-time communication. You have WebRTC for audio and video. And you also have local storage and other storage syncs so that you can keep data in your browser even when you're not connected. So client side, we have a lot of different technologies to use in this modern stack. On the server side, there's Node, and it's been around for a little while. Reached version 10, they're working on 11, and soon 12 will be out, which will be the next stable. The interesting thing about Node is that streams, sockets, and services are the things that you're going to find on Node that are above and beyond what you would see in other languages. Each of those is its own 30-minute talk, so we're not going to get into that, especially streams, because those are particularly interesting. But on the server side, so you have Node, you have real-time communication, and you have data bouncing all over the place. You've also seen changes in databases. We've gone from the SQL sort of paradigm to this schemaless NoSQL with JSON data being transferred around. Cleaner upgrade paths, but there are some trade-offs, of course, ACID being one of them. So in our modern JavaScript stack, all the way from the client to the server, we can run JavaScript now, which is a pretty impressive feat. But we have a lot of moving parts, and we have a lot of things that can go wrong in a stack like this. But before we get into what we need to test and what can go wrong, what can we deploy? What can we build? So in this modern JavaScript world, we can build two types of applications. Hyper-connected, and what I would like to call temperamentally connected. So the hyper-connected are your real-time applications, your multiplayer games. These are the things that take advantage of all of those HTML5 glorious things, such as WebSockets. You've probably seen products that are like analytical dashboards or social applications or chats. All of these running in the browser or on your mobile device. But they rely on things being connected all the time. You're constantly going back and forth between the server. Now, on the other side of things, there's these temperamental services, these temperamentally connected apps. These are the ones that are on your mobile device, that are they're either the mobile websites or the PhoneGap and Titanium packaged apps, or more frequently or more recently, Chrome packaged apps. These are the applications that don't rely on being connected to a server. As a matter of fact, most of the time they're not. And there are situations where you'll be connected, you won't be connected. 3G drops, Wi-Fi drops, doesn't matter. In these contexts, your application needs to know, what's going on, how to handle those disconnects, and you have to simulate and test those sort of scenarios. So how do you do that? How can you cover all of these situations when you go to test your JavaScript application? So on top of that, we have a couple other challenges. First of all, not all JavaScript is created equal. There's V8, there's SpiderMonkey, there's whatever Internet Explorer uses these days. All of these look at JavaScript just a little bit differently. And you probably had those scenarios where your boss has called you up if you work with JavaScript and said, well, my mom tried to load your app, and her Internet Explorer 8 wouldn't do it, so can you rewrite the whole thing? No. No, this is not modern JavaScript. We need to stay away from that. The other problem with JavaScript is that being that it's out there, being that it's so ubiquitous, it's very fractured. All mobile browsers use something different. Chrome versus Safari. You have different versions, you have different older phones, newer phones, you have different browsers on tablets and computers. So you can't please everybody. And then the same on the application side. You have your MVC, which is a very challenging thing when it comes to complexity. It gets more complex, and hundreds and hundreds of models and files, and all of these things lead to more tests. And because you're running it in all of these different environments, you have to, those little hacks that make things work just perfect in everything else. So again, you can't please everybody. So next, in a full testing stack, we need three things. And of all these challenges, yes, I've narrowed it down to three simple things that you need. You need an isomorphic test runner and reporter. Isomorphic means that it will behave the same whether it's on a server or in a browser or any different browser. So you need something that behaves very consistent everywhere that it's run. Number two, you need an assertion framework. If you've used QUnit or any of the other ones, usually your assertions come with your test runner. Things are sort of changing, and we'll get to that in a minute, of what can you expect from sort of this new level of your assertions and your test runner being separate. And then the third thing that you need, which is something that is new, very new, is that you need a way that you can test on your device, on your mobile phone, on your tablet, on your different browsers, different versions, the whole grid. So you need this multi-environment test automation, and eventually you get this continuous integration thing. You want to write your code, push it to GitHub, Travis takes over and runs all your tests, and you know which browsers you broke. That would be fantastic if it was so easy, and it is. So the first thing we're going to talk about is the test framework. Mocha is my choice. It's simple. It doesn't come with all of the things that QUnit or Jasmine come with, so that I can bring in my own tools, things that I think will make my testing environment easier. So it sort of gets out of the way. we're not going to get into discussions and arguments about which is better, TDD or BDD. You probably all have your own opinions. Keep it to yourself, please. Simple asynchronous testing, because JavaScript is, you know, asynchronous and can get some challenges and call back hell when you start nesting things. So you need a way to manage that. And of course, it runs in Node.js and all of those modern browsers that we need to test. So if you haven't seen what Mocha looks like, this is an example that demonstrates sort of the basics. I'm using the describe and it in this particular example. I'm going to connect to a database. This is actually more of a node example than a browser example. So I have my database, and then I have 3 records, conferences. And so before each test or it statement, we need to flush the database, check to make sure that if there's an error. Right here you can see that there's this done. If it is, we're going to tell Mocha about it. Else, we're going to save these 3 things and then wait for that to finish and head on to the next step. Continuing down this line here, we're going to describe a find, and it responds with a proper match. Again, asynchronous. If this, you know, was just synchronous, we could leave it out, but it's not. We want Burgas, and so our database is going to go look for it. And this is these 2 lines here are our assertions. I'll get into these in a little bit, but so we check to make sure if there's an error. Hopefully there isn't. And then we check to make sure that we had 1 conference returned, and then we're out of here. Pretty basic, pretty simple. Mocha doesn't really do much in this. More of the power is in the reporter. And Mocha has a lot of different reporters. So you can have your lists, you can have your tap, you could have streaming JSON to send it to wherever. Or you could even go so far as to integrate it with coverage. So if you wanted to do code coverage support, that is also available. So that covers Mocha. Pretty simple, gets out of your way. The next is Assertion Library, and we're going to go with Chai. This is the point where I get to talk about my work, because Chai is one of my libraries. I ran into a problem where I was writing code, some modules that needed to run in both Node and on different browsers. So at the time, Mocha was sort of brand new, and it didn't come with an assertion library, and there wasn't any written that could handle these sort of scenarios. So Chai's first version came out. We have supported assert and sort of the expect style and should. And those have remained 3 assertion styles, of which I will show you right now. Chai allows you to basically choose your own adventure when it comes to testing. You can either go with the classical assert style if you are old school, of which we've added a little bit of syntactic sugar. If you need a little bit more backwards compatibility, but like a more expressive, sort of self-documenting test style, you can go with expect. And then last, there's should. And should is sort of the new style, and it does some kind of fun and funky things to be able to extend all of your objects in your JavaScript so that you can basically do whatever should, and then continue on with your assertion. They're all chainable, and you can just keep listing them, and there's a lot of different things that you can do with should. And I don't know, if you have a personal preference, mine is should. I like it, it's self-documenting. It sort of just is enough that you don't even need comments in your tests. It's very nice. The other awesome thing about Chai is that it has plugins. Chai's plugins basically allow you to integrate with your own sort of, if you have any sort of vendored things that you do. For example, if you work with Synon or jQuery or Backbone, you can use Synon's like stubs and mocks and spies, and then integrate it right with Chai, and your assertions will just read the same way. If you want to do assertions on jQuery objects, we have that capability. Or if you're working with Backbone and you want to trigger events on your models and test that they responded correctly, you can do that as well. There's also a couple more independent plugins, such as spies and JSON schema, which allow you to do various more complex assertions on data and functions, function calls. There's currently 16 plugins at the Chai website, and a very large repository of documentation. So if you are looking to write your own plugin, that would be a great resource for you. Right now, we've seen a lot of sort of these public plugins where people, vendor integrations mostly, but one of the things that hasn't been tapped is where you write your own plugin specifically for your own use. And people either don't do it or don't talk about it, but the plugin API is so easy that, like, if you are testing a database model often, that you can just write your own plugin so that it integrates with whether you're using Mongoose or, you know, AngularJS. You can integrate with your specific model so that you're always testing consistently for every instance of this. I would love to see more of that, so if you are into testing, feel free to ask questions about that. And then the last part of our stack is something new out there called Karma. No code for this one, simply because it's more of an environment tool. What it does is it basically connects to your local browsers, and it opens up your test website, your test page, runs your tests, and then reports back. So you can, from the command line, invoke all of your tests on all of the browsers that are installed on your computer and get responses back quickly. You can also do it headless in Phantom.js, or if you're really crazy and adventurous, you can run it on your CI server, whether it's Jenkins or Travis, and you can have it connect to Sauce Labs and run your tests in every variation of every browser's version, which can get a little crazy, but might be something that you need. Karma is new. It used to be called Testacular, but they renamed it, so if you've actually heard of that, you have heard of this. And it's something that if you are building these full-scale applications, whether you are building Node all the way up, or if you are doing something with Ruby or Python and then have a UI on top of it, these are the things that you should probably be running. That's all I got.
Right, so if you've got any questions, you either ask them in English, or you can do it in Bulgarian, and then I can try to translate.
Do you think you can show some of this in action right now, or you need special setup, or what?
I don't know what is on this computer because it's not mine. What I can show you, or not. There we go. Okay, so this is Chai's website. We actually provide for anyone who is interested in using Chai the test suite that runs Chai, which runs on Mocha and runs in the browser. So this is sort of a stylized version of what Mocha's HTML reporter runs. Fortunately, one is failing. This would be an extension. It's causing Chai to drop this particular assertion. So this is what the reporter for Mocha looks like in the browser. And this is running all of the tests for Chai. You can actually go and see the source for each of these. So these are some more examples of here we go. So you can do deep equality. You can also do deep property. So these are You can provide an object to chai and then provide like just a string path, and it will test to make sure that whether that path exists or not. You can go even farther. Oops. And check for an actual value in that D property. And the same is for should. We run all of our tests for property. All sorts of stuff. And this runner that is actually running the test is Mocha, so I can refresh and you can see that it runs all the tests in the browser. If you run this in, for example, IE, or you'll get different results, or Canary, Chrome Canary, you'll get different results. That's.
If you're running in multiple browsers?
Yes.
You need some kind of agent outside the scope of the browser, right?
Right. So you could use, that's what Karma does, is it basically abstracts that layer. And so you provide your tests, and it will open up your browser, open up your tests, and it actually hooks to Mocha and detects fails in Mocha's run cycle, and then reports it back to your console.
And if you need this to run headless without the UI, is it possible?
Yes,
yeah.
You can either run via Phantom, which is the WebKit engine, if you just want the WebKit engine. If you're looking for multiple variations on browsers, Sauce Labs, which is runs Selenium, Karma will actually connect to Selenium, and you can specify which browsers, which versions of each browser, and it will run on their environment for you.
Cool. Any other questions?
Wow.
Някой? Okay, let's thank Jake. Like if you have any questions for him, you can grab him. And now I'm going to make a few announcements in Bulgarian. Да, ако искате ни дадете някакви пари, ето тук е кутийката. Ако искате да правите Lightning Talk, ето там е дъската. А сега ще правим обедна почивка. Има сандвичи от Subway, както казахме, те са безплатни. Има вегетариански, ако не ядете месо. Отзад има една малка приятна градинка, в която ще направим нещата, така че посоката е навън, по стълбите надолу вдясно и повече се ориентирате. Като има и няколко бутилки студена вода отвън на масата, така че ако искате студена вода, си вземете. Продължаваме.